improve soil and water, downstream agricultural productivity. We create jobs, and we improve the lives of not just the 1 billion people that live in forests around the world. We improve the lives of everybody around the world because we all depend upon the products that come out of these environments. And when we plant 500 billion trees, we will sequester enough carbon dioxide to change the trajectory of climate change. Now that is something to think about. Now governments have recognized this, and commitments have been made to restore 350 million hectares around the world. Now to put this in context, this is an area the size of India, and equates to about 300 billion trees. And it's not just any governments that have made this commitment, it's your governments, led by these amazing visionaries and amazing change makers. The most notable of which, of course, is Wangari Maathai from Kenya, who was the first African woman to win a Nobel Prize and deeply tied to the environment. But of course, we have to recognize the local work of like Mohammed bin Majidub. In terms of important issues that are being led by the continent of Africa, includes by the African Union, the Africa 100, which has made a commitment to restore 100 million hectares across Africa. And this is 24 countries that have made this commitment. And it includes the Green Belt, the Green Movement, the Great Green Wall, and a lot of other countries around the world, around Africa. Now, this is really great, but what is the overall issue? Well, the issue is that this is the state of the art at the moment, where we're dominated by hand planters who, this is the only thing that we've had. So how do we take all of the work that we've done, all of the really great, amazing things that are being done by people around the world, and scale that up to a level that we are able to hit the size of the problem from a global level? Because this is physically dangerous. It's hard to get enough people into the area, and sometimes it's hard to actually get the labor to do the basic work. So achieving these commitments with the current planting methods is going to be impossible. They need help. So for the last 2 decades, I have been a NASA engineer, and I have been working in a number of areas. And while I was part of NASA, I was studying climate change and deforestation in particular. Now at COP15 in Copenhagen in 2009, I finally made that emotional connection to the issue of how fast our forests are coming down around the world, and yet why I was really puzzled as to why is it so difficult to put these back together. And it didn't take too long to understand. It was because we're really limited by hand planting. And so we asked ourselves the question: how can we increase the planting rate while simultaneously increasing increasing the planting rate while decreasing the cost? And so that is where we came up with our solution. Now, our solution works with 3 major components. Data is everything. Understanding how to restore an area, what you want to plant, is the first step. And then the next piece is we have our planting drones and a seed pod, a biodegradable seed pod that helps us deliver these seeds. So let me give you a short video. Now the way it works is our first step is to take detailed images using both satellite data sets and data sets that we take from our drones. We take a look at the topology, the soil, and the biodiversity. And we use that information to create a precise planting pattern. Now this planting pattern, once we have it, is then uploaded into our planting drones. These fly at 3 meters off the ground and fire a biodegradable seed pod at each of the predetermined positions. These penetrate the earth, are activated by moisture, and contain all the nutrients necessary for healthy tree growth. For an example of the mapping technology, we are currently using this as one of our main systems. Now this is a piece of technology built by a company called Sensibi, which is also used in agriculture and has great opportunities in that market. It has a flight time of about 45 minutes and allows you to take those detailed images, both in visual as well as other types of frequencies, so that you can understand what is the health of your terrain. So for an example, once you have the data, you can produce a three-dimensional map that you can use to evaluate how predictive is your area. You can learn things like productivity, where red here indicates high stress and green indicates that it is a good product. And so in the red area, you'd want to make some changes in how you're managing that terrain. Or you can do a digital elevation model. This is a topology model that allows you to understand drainage patterns. So if you need to know where water is pooling or change your areas, you can learn these sorts of things. With that information, we load that into our planting drones. Now this is the one that we flew yesterday. It was designed by two of our engineers who are in the audience with us today. And it has a total flying time of up to 30 minutes. And we can carry about 10 kilograms of actual seed and payload. Now the one that we had yesterday, you can see the drone, but underneath it is the planting mechanism that is mounted there, along with the seed pod feeder, and then the pressure tank. So I will show you the potter in just a second. To give you an idea of how big it is, this is Engineer Spencer next to the drone, and so you can see it's actually quite big. The podding system, it currently plants at 2 pods per second. That's 120 a minute. Now to put this in context, a typical hand planter for trees is planting about 1,500 trees a day, a really good one. Our technology, with 2 people running this system and 10 drones simultaneously, which is what we can do, will give us the planting capacity of 400,000 per day in comparison to 3,000. So this is a significant change. Now imagine what can happen if you train the local population to use this type of technology, and instead of having to plant by hand, you get them out there using this type of technology, and you can see that they're planting at 150 times faster and typically 4 to 10 times cheaper. And this is how we enable a global scale restoration, by getting our great people who are already in the field and giving them a better tool, a better shovel that makes them more productive and more efficient at what they're doing. We also have a system that is dry seed spreader, and this allows you to do a different type of delivery of dry seed, which is also a preferred method. I want to give you just a couple of quick examples. This is mangrove restoration in Myanmar. Now the thing about mangrove restoration in Myanmar, and I showed you that picture earlier, people out planting, this is an environment where you're up to your knees in mud or up to your waist in water. So it's a very difficult place to put people. And this is where our technology really comes to the front of being important, where when you can't get people into the area, this is the technology that enables you to do restoration when there is no other way. And then, just to show it in action, this is over a mangrove field in Myanmar, and you can hear it firing. So you can see how fast it is. It goes very fast. In an agricultural field, we can actually fire through water. Up to 10 centimeters of water we can fire through. Now this looks quite slow, but this is the actual speed. And you can see it firing into the water there below. So, very impressive. One other that I would like to show you is the case of mining. Mining restoration, of course, is an important part of our world. We depend upon the minerals that are being extracted, and many economies in all of our countries depend upon that industry. But we also need to make sure that these industries are being good actors, that they have the capability to restore these areas after their work. And here is an example of us working in a post-mining operation in Australia. In this case, we are flying along a furrow that has been dug. Now, this is fully automated. We program it, we put in the pods, and then the drone will launch by itself. It will follow the furrow, plant the seeds and land by itself. So these are fully automated systems, and this is what helps power us through. To show you what that planting looked like, you can see each of those dots represents a point that we planted, and you can see how accurate that was in that instance. Now, who's paying for trees around the world? There are many mechanisms, and many of these mechanisms are very important because these provide opportunities for each of the countries around the world to apply for funds from these major funds to be able to do local restoration work. And so these are things that you can think about as you head back home to your own home countries, is how can you help your local communities create projects that can access these sorts of funding. And of course, the technology that we can provide is one thing that would be really helpful in enabling you to complete the work. Now, one of the other things, of course, is if you notice over to the back there, the Sustainable Development Goals, which of course this conference is deeply tied to. We were invited by the United Nations Foundation at the launch of the Sustainable Development Goals because they believed that our technology is one of the most important enabling technologies to get the environment restored. Now, of course, 15, Life on Land, is the one that we're most directly tied to, reforestation. But of course, when you get it to a large enough scale, you can affect global climate change when you get enough trees planted. By 2038, we will be planting 10 billion trees a year, which will allow us to sequester about 1.1 billion tons of carbon dioxide out of the atmosphere. And it climbs from there. So we will end up being a significant contributor to the reduction of atmospheric carbon as we go through the ages. Now, once you restore the area, you have to remember that if you do it at large enough area, it has significant local benefits. Everything from creating clean water, more food, so you reduce hunger. Because you're creating local industry off of the materials that you're sustainably harvesting from these areas, you're able to create jobs, which creates economic opportunities at the local level. And that leads to better health, decent work, and reduced inequalities. And this number down at the bottom is really important. For every dollar that is spent in reforestation, $7 to $29 is generated in local benefits to those local populations. So if you're looking for ways to make sure that you can help grow your local communities in the rural areas, this is one of the best ways to do that. And the other fact that I'd like to point out is that on coastal mangroves, every hectare of coastal mangroves produces $194,000 worth of local benefits. That's to improve fisheries, that's to improve materials. So again, this is where you as a community can invest and have real economic return. Yep, I'm almost in conclusion. So we have lots of partners around the world. We've created great MOUs and organizations, and we'd love to add all of you to our deck. And so that's it. So, thank you very much.